Hi, this is János, it's Reword Audio, and today, as you see, I'm back at home, and I'm going to talk about something very interesting. And I wanted to make actually this video about half a year ago, because half a year ago I did something to my amplifier, and I would like to talk about it. And specifically, if you are in a rush, this is about a single-ended amplifier, vacuum tube amplifier, and I was adding a gas tube regulation for the driver stage. And I'm going to talk about the experiences that I had with that, and I'm going to also expand on afterwards about what you can expect from upgrades and what is the point of them and the meaning of them, and when is it that you already had enough upgrades and you are just chasing your tail like the dog chasing his tail. And and also about upgrades, are they equivalent to each other, or different types of upgrades will get you to different destinations? And yes, they will get you to very different destinations. And here I'm going to show you a little guide about, especially today, about regulation. Where will this lead to you? And stay tuned. So let's get into it. So here we are. So this is my amp. And as many of you who have been following my channel, you already know about my amplifier. So this has been my main amplifier for the past 25 years. And of course, during that past 25 years, it went through many hundreds of modifications and rebuilds. So that's why you see like tube sockets there and sockets for pots. And as you see, like here, this part is like totally destroyed where the output transformers are sitting, because as you see, at one point there was a vacuum tube there and another vacuum tube there, and different output transformers. So this thing is like a Swiss cheese or a sponge cake, and there's pretty much more holes in this chassis than metal at this point. If you go see in the back, there's also like tons of holes. So this amplifier has really been born as a babe and then matured into the amplifier it is now. So actually, this has been born as my darling amplifier, and as you see, it had enough space in it. I built it as a giant amplifier. That's what my recommendation is. Whatever you are planning, just build twice as big a chassis, and then it will give you room to upgrade and play around if you want to. You don't have to. That was one of my lessons that I learned during my 25 years in modifying audio gear and stuff, is that really my darling amplifier was a double DC darling. So I had two darling power tubes in parallel, and these tubes were direct coupled to the driver stage. So that's how it's different from my pure darling or basic darling that I shared. And that way the power supply was 450 volts DC. And that's why what I shared was the cap coupled darling, because it's much easier to build in a way that it's a lot safer. If you accidentally zap yourself by 200 volts, not a biggie. Hopefully, you can still kill yourself by such a zap, but it's relatively extremely rare, and in most cases it just leads to a ouchie. That's what you say, ouch, and that was it. But when you get zapped by 450 watts, then that's not an ouchie. That's a biggie, and that's usually leads to a funeral. So that's why I did not share anything like that on my channel, how to build amplifiers with 400 volts and plus on the power supply, because that's like really hazardous, and I just want you to get comfortable at 250 watt range, which is a lot safer, like 10 times safer than 400 watts. And what you see here, actually these power tubes are running at 750 watts DC. That's what it morphs into now. So this is like, even I dread to think what would happen to me if I accidentally touched 750 watts. I never zapped myself with 750 watts, but my mentors too, once he had a zap of 900 volts, and that was like a really brutal experience. So this is, well, not 900, just 750, but in this range, when you have when you touch that kind of voltage, it basically contracts all the muscles in your body. So this is not just a zap and you are done. No, it's every single muscle contracts at full force. So if you are sitting in a chair, you'll be thrown out from your chair, and also where you get zapped, the flesh will burn. So you will have a deep burn. And in most cases, the danger by zapping yourself with such high voltage is number one, the injury that you suffer by being thrown to the other side of the room. Your body will propel you much further than you can do by your own force. Like for example, Stu, my mentor, he found himself at the opposite side of his room, and that it doesn't matter how hard he tried to jump, he couldn't even jump halfway through the room. And when you get zapped, all the muscles contract at full power, he was at the other end. And also, the other thing that usually happens when you get zapped by that much electricity, you also, sometimes the amp falls on your lap, or you get it falls on you, so that also more damage. And provided you survive this experience, because it stresses your heart like nothing else, the burn, usually you get a deep burn where you get zapped, and in most cases people get severely ill or die from the septic shock caused by your burned flesh decaying you from the inside and killing you. If you don't get, even if you go to a hospital, sometimes they cannot do much about it. Maybe they can amputate that part, maybe not, but maybe it's not so bad, but it can get that bad. And usually most people die because of that complication from the burn itself, provided they survive being zapped by this much voltage. Anyway, so I did not want to talk about that, but safety first. So it's really always good to know what we are dealing with. So okay, so what I did, you see these purple glowing tubes. So these are the tubes that I have added, and these are basically the vacuum tube equivalent of a Zener diode. And you are saying, well, János, why didn't you use a Zener diode? And my answer for that is because Zener diodes have their places. So when I have used them, I tried them in many different functions, many different places, and at the only place I can put a Zener diode, and it does not affect the sonic signature in a way that it pushes it towards a mechanical sound, is when you have a pentode, and you tie the pentode to a triode mode. And you can do that by putting a Zener diode between the screen and the plate. So if you put like a 6 volt, 6.2 volt Zener between there, like in this case, these are KT66 tubes, and then you can put a 6 volt Zener or 8 volt or 20 volt, doesn't matter. 6.2 volt Zeners are usually the best. They offer the best regulation of all the Zeners, the most stable voltage, so that's why I like to use those. So if you put that between screen and plate, then they will not impact the sound. They will not give that transistorized, artificial, beefed up sound as they would give if you would place that Zehners to regulate the voltage, the B plus supply for these tubes. So in that operation, when you put the Zehner between screen and plate, then that will be really good, really beneficial. And why would you do that? You want to do that because you want the screens to sit at a lower potential than the plate, because you don't want the screens to be the electron sink. You want the plate to be the electron sink. So what that means is that you want the screens to limit the electrons that flow through the screens, because the screens are really tiny wires. So you want to, even if you can like triode connect a tube, like KT66s, the tube manual says, yeah, you can triode connect them. But even then, just put like a small resistor between the screen and the plate, or a Zener diode. So my friend Rishi in Australia, he started using that, and I learned that trick from him. And I think he learned it from Stu, my mentor. Maybe. I have to ask Rishi about that. And because Rishi also used to live here in Hawaii, and that's where I met him, talking to Stu. Yeah. And so the world is small. Anyway, back to the power tubes. So you always want to have the screens protected, and the Zehners there, they just do not act as a solid state sounding device when used in that operation. However, here in this case, what I did is I added these gas tubes to regulate the B plus voltage, the high voltage for these tubes, which here one and the other. So these are the driver tubes. And why I did that? Because for a long time, I used the same high voltage source for the driver stage in this amplifier, and that has been the Achilles heel of this amplifier. As you see, this amp has two parts. One is this chassis, and there's also another chassis next to it with a really big transformer, a smaller iron, and a tube and two switches on it and a meter. So that thing with the two iron on it and the tube and the switches and the meter, that's the power supply for the high voltage. So that gives the 750 volts for the output tubes. That's generated by a separate chassis and separate transformer and choke. This thing is a choke there. And the power transformer that generates the B plus for the driver tube is in the amplifier. So for those of you who have now a Darling amplifier, the power transformer inside was the original transformer for my Darling amp, and what I did is I kept it, and it's just feeding the driver tubes, and for the output tubes I'm using an external source that can deliver higher voltage, higher current to feed a different tube than the tubes that I used for my Darling amp. And what else? So basically, over the past 2 decades, I really pimped out this amplifier to have the best, well, not best, but a really good and excellent B plus supply for these tubes. And what you don't see here is that I have a transformer and a choke, and that feeds the amp, and inside this amp I have 2 additional chokes, each one filtering separately for each channel for the power tubes. So I have a really nice 2 choke in for the filtering for the power tubes, and that's a really nice thing. And inside I also have a DC link capacitors that are fed by the second choke, which is inside the chassis, and those are as big, those actually are bigger capacitor than this choke here. So there's two of those giant caps inside the amp, inside the chassis, and they are bigger than this choke there. So, and they are actually 1.2 kilovolt rated, so 700 volts for them is meh. And why I do that? Because if you use much lower voltage on your capacitors than the capacitor is rated for, then it does not radiate a big electromagnetic field. So capacitors, when they get stressed by applying as much voltage onto them as they can take, then they radiate a lot of noise and become really noisy. But if you use about half the voltage or 2/3 of their peak voltage, then they just radiate a fraction of the noise that they would normally radiate. So that's a little trick for all of you. So what I had is that I think, in my humble opinion, the power supply for the output stage was pretty good. I was happy with it. And yes, I could have improved on it by higher quality parts, etc., etc., etc. But it was good enough for me that it brings tremendous musicality. And I would say, in my most humble opinion, the best sound I ever heard at any places and any amplifier giving any sound. Already it was capable of producing that. So do I need to improve it? I don't know. Are there other amplifiers that are better? Probably they are. Have I heard them? No. So as you see, I really don't make these videos to say I have the best stuff in the world or I give the best advice, but I just want to put everything in their perspective, is that things can get good enough for you to enjoy, and certainly me building my things and enjoying the process, it really took me to where I wanted to get with stereo. Because usually when people are buying their stuff and they don't get into building, you always are in a rat wheel, just dog chasing its tail and the hamster just going around, and you are never satisfied. You always go to audio shows and you, oh my god, this sounds so good. You go to friends, oh my god, their stuff sounds so good, and I need better and better. And for me, no. For me, what I have, the sound I have, is the sound I want. And I don't go to audio shows now anymore because it's just like tremendous disappointment, and it's like really wasted time to. And somehow when I talk to my friends and buddies, they all say that yeah, they are just getting bigger and bigger disappointments for higher and higher price tags, and it's really rare to have a room where you have good sound. And yes, there is sometimes, but in most cases, just the prices are getting totally out of proportion, and it's not giving us the returns we are looking for. So back to here. So I was already really satisfied with my amplifier, but why I did what I did? Because it was bugging me that my driver tubes were really restricted, because their power supply was a simple solid state rectified power supply. What did I use? I think I used Cree diodes, and then I had like a capacitor, resistor. So resistive filtering, which is just not as good as it gets, because it is just really limited. And that's what you also get with most commercial stuff. The driver tubes are almost always resistive supplied. And for ages I really wanted to upgrade this to a proper vacuum tube rectified, almost like choke input or tuned capacitor input, which is still behaves like a choke input supply, where there's a tiny capacitor in front of the choke that actually lifts the voltage a little bit, so you get like a higher voltage output, but it's mostly choke regulated. So the choke still acts as a regulator. It still acts. It does not behave as a capacitor input supply, and that gives a very different type of sound than the capacitor input. And I would say very different type of sound. The difference is actually not that big. It depends also on what kind of material you listen to, what speakers you use, etc., etc. So there's like sometimes the difference might be night and day, and sometimes you might not notice the difference. It also depends on what music you listen to, what you listen for, and what are your associated equipment. And in my channel, I'm giving you a lot of advice that if you have built your system like that, in that case, moving from a resistive to a supply or like a capacitor fed power supply to a choke input supply, that will make a notable change. So now I'm going to talk about that change, what I heard was in my system. However, in my case, I did two things at once. So I did not change only the capacitor input in the power supply, but I also changed adding the VR tube regulation after that. So now what I have is just like a tiny tuning cap, I think like a 1 microfarad cap after the vacuum tube. So this is the 5T4 that I'm using as a rectifier. Actually, I could use like a 5AR4, 5R4GY, or 5R4GWB, or 5U4, etc. So lots of tubes can be placed here. It doesn't really matter. Now I just put in a 5T4 because that was the easiest for me to grab. For those of you who are looking into vacuum tube rectifiers, this 5T4 is a metal jacket tube, so there's also a glass tube underneath, but they put it into a metal jacket. And so you cannot see the glow of the tube. The only way you see it's working, that it's hot. And this is like a super cheap 5AR4 alternative. So if you cannot get like a Mallard 5AR4 or some US NOS 5AR4s, then this is a nice alternative. It certainly sounds a lot nicer than the early Chinese and Russian 5AR4s. I don't know how they sound now. Probably better than they did 20 years ago. Maybe if you have experience, you can comment about that. One thing I can say is that what I hear from people is that modern production tubes are getting much better in the sound than they used to be 20 years ago, but I don't know about their longevity. I don't know how long they last. Do they long laster than they did 20 years ago? Because, for example, this 5T4, it just will last you forever. Like, if you get a tube, it probably will outlast you. For most of us, like 50 years old or plus, if you put this in your amplifier, the amp will change owners. Probably your son will inherit it first before changing this tube. So, and I doubt any modern production rectifiers will outlast you. I don't think so. But if they do, please comment. Probably from other world, someone's ghost will contact us that, yeah, my Russian 5AR4 outlasted me. Anyway, so getting back here, so what I did is just like 5T4. And after that, I have 1 microfarad capacitance just to give a little higher voltage output. And then I have a choke, and the choke is on the inside. You don't see it. What you see here, oh, I know, you see it. This big thing in behind, this purple painted, purple gold thing, that's the choke. and behind the rectifier, that's the filament transformer for the rectifier. So, and I had really hard time placing it, so that's why it's at 45 degrees. But hint, don't place iron at 45 degrees, place them 90 degrees to each other. That's how they pick up the lowest level of hum. But in this case, because I also, on the other side, inside the chassis, I also have transformers and parts, so this was the only way that I could fit it on the chassis. So that's why it looks like that, because it's overcrowded. But if my chassis was a little bit longer, like 1 inch longer, it would already be like nice 90-degree angle to everything else. So that's what I recommend. So sometimes I also share with you what not to do, what I'm doing, but sometimes you can get away with it. So, and I know when I can build things like to get away with it, and sometimes you cannot get away with it. And here you can get away with it, or I could get away with it, because it's kind of far away from my output transformer. And this thing to it, that's also a filament transformer. So they are not going to affect each other much. These are really low voltage output that they have. And I'm not stressing them out, so they both have much higher current capability than what I'm using them for, and in this case it's not a problem. But if you are using your filament transformers and you are stressing them out, like you have a 2 amp rated filament transformer and you are running them at 2 amps, or maybe 2.2 amps, you are pushing them really hard, and you also have your output transformer closer to them, then you are going to have a hum problem. So that's why a little experience with them and knowledge goes a long way. That if you are not stressing your transformers, then you have a little bit more leeway on how you orient them. And of course, the distance, the further away the transformers are, or chokes from each other, the less they impact on each other. And you want like your power supply choke as far from the output transformer as possible, so these are like really far away, really nice. And in this case, look at the other side. My output transformer and that choke are really close to each other, but they are 90 degree to each other, and they are not picking up, it's not picking up anything from that either. But there's, on this photo you don't see it, but there's like 3 inches or so distance between the two of them. But if you would put them right next to each other, oh man, it would hum like crazy. Don't do that. So going back here, what are these tubes? So these are voltage regulator tubes, VR tubes. They are called VR150 or OD3. These are the two names. It designates the same tube. It has two names. The VR150 is the military nomenclature, and the OD3, that's like the normal nomenclature. And the VR150, it means like 150 volts. So voltage regulator 150, VR150. It tells us what is the voltage that they regulate. And these don't work like Zener diodes. So they are not analogous. So if you have a circuit where you have a 150 volts Zener string or a single Zener with 150, you cannot put a VR tube instead of that. They are not swap. You cannot swap one for the other. You can swap a VR, no, you cannot swap them, because they work in a really fundamentally different way. So what the Zener does is that it drops that amount of voltage over itself. So one end and the other end always has that much voltage difference. And how the gas tubes work is that they are fed by a regulator series resistor, and the voltage drops across that series resistor, and they are run really hard. So those series resistors will cook like crazy, and you'll have to use much higher wattage rating resistor than you would normally use if you calculate what wattage they use, because of the high voltage dropping through those resistors will stress out those resistors a lot more than as if just using them in a normal duty, dropping that much wattage. And you can burn out a lot of resistors before finding one that can take it, because even if it says 20 watts, it still can go up in a smoke. So for example, there's like the Dale resistors, you know, the one with that metal housing, the heatsink housed, those ones, they are really good, they can handle this sort of operation. But other kinds, you'll have to really experiment, and I recommend just not using one resistor, but 2 or 3 or 4 resistors in series to handle that voltage drop, because you want to drop at least 100 volts or more across that resistor that regulates it. I think I will make a separate video on how to use VR tubes if you are interested. Because that is something that is not really common knowledge, and it's really hard to find anything, and I've seen a lot of really bad examples when people nowadays use VR tubes. Is just, oh my god, you don't use it that way, that's just asking for trouble. So now it's 30 minutes and I still haven't shared what my experience was. So basically, after I changed the B+ supply for the driver tubes to running them with the VR tubes, the tubes are still getting the same 320 volts feeding supply as they did before. So like the B+ voltage didn't change what they see. However, because of the VR tube regulation and the choke input or tuned choke input power supply, it has a very different sound than it had before. And now I am at that stage in audio after like 25 years of basically trying out everything on planet Earth. I would say that nothing surprises anymore, but what I experienced here did surprise me, because something happened that I did not expect at all. And something also happened that I expected, and that change was exactly what I thought. So the amp became even more dynamic, even more quiet, and I would say a lot more competent than before. But it really did not matter to me, because it already provided for me 100% musicality, that to my experience, that as I experienced music, I could already 100% connect to music, and the amp was never in the way of listening to music. But with the regulation, what changed was that after that, the low quality inputs, the quality of them just increased tremendously. And what I'm saying is my computer. So when I just use my laptop and the headphone jack output from the laptop, it doesn't have like a Genius sound card in it. Just like really basic stuff. Don't think it's like a $20,000 streamer or something like that. Not that type of digital out. Just plain vanilla computer sound, which is supposed to be like outrageously bad, and it wasn't really good before. However, after having this modification with the VR tubes, oh my god, that low level input just drastically transformed, and also like all my digital sources, they just jumped up from worst to best. They absolutely transformed. I would say my vinyl, there was just this tiny incremental improvement with it, but digital, night and day. So for those of you who use predominantly digital sources, or you have like a modest DAC or streamer, and you are thinking how you can improve your sound, what that can give you the biggest jump in sound quality is like, don't go for a $50,000 streamer. If you have a tube amp like a single-ended triode, just change, if you can, add gas tube regulation for the driver tube, and that will bring you like a massive improvement in how your digital sounds. It will just start to soar like an eagle in the sky. What an analogy. Come on. Anyway, what else do I want to share? So basically that was something really unexpected for me, and also it really made a difference in it being, I would say, kind of immune to the power fluctuations in the line AC. So when I had just the non-regulated power supply, the capacitor input, resistors filtering, then it was a lot more susceptible to when the line AC dropped, or there were problems, neighbors using too much, too many computers in the neighborhood, etc. Then the sound really tanked, and now I don't hear this tanking anymore. So I always have like a guaranteed minimum with it, and I realize that I rarely ever go to my capacitor bank or my other power supply, I mean line correction devices. I rarely turn them on since I have this, or I have to fiddle with it 10 times less than I did before. So that's another huge benefit for regulating your driver tubes. And then you say, János, why don't you regulate the power tubes? Is because these VR tubes can only supply enough current for a driver tube. They cannot supply enough current for power tubes. So the only way you can use it for power tubes if you are using pentodes, and then you can regulate the screens with VR tubes, and in that case, if you regulate the screens with VR tubes, oh my god, your amps will go to the stratosphere compared to having them regulated by Zeners or unregulated. It will be like your amp will just, you won't even recognize it. So I think that's it for now, and now I blew past half an hour, so this is again back to my old longer format videos. And if you are still here, thank you for listening, and hopefully you will try out VR tubes, and I really recommend VR tubes. I've been playing around with them for over 20 years, and if you are still using preamplifiers, goodness, it just like takes preamps to a next level if you have VR tube regulation for them. So thank you for listening. Please share your comments, share your feelings and adventures. Have a wonderful day. Bye bye.